Okay, so just a reminder when we're doing orbital notation, a box represents an orbital. So every S sublevel that we have only has one box because any S sublevel only has one orbital. On here, any P, I have the 2P and the 3P, it's going to have 1, 2, 3 boxes because any P sublevel has 3 orbitals. I also have a 3D on here, which has 1, 2, 3, 4, 5 boxes because any D sublevel has 5 orbitals. The other thing to remember is that one arrow equals an electron. Okay, so let's do something like calcium. Okay, so calcium has 20 electrons, and I figured that out because I looked up calcium on the periodic table. Its atomic number 20, has 20 protons, so it's also going to have 20 electrons. The Aufbau principle says we start with the lowest energy orbital, which is the 1s. So each orbital can fit a total of 2 electrons. They have to have opposite spin, so you do 1 up, 1 down for your arrows. So now we've accounted for 2 out of the 20 electrons. The next 2 are going to go up here. Okay, so now we've accounted for 4. When you get to the P's, since they have orbitals of the same energy, you're going to do 5, 6, 7. Now you pair up 8, 9, 10. So far I'm just keeping track. We've dealt with 10 electrons. We need 10 more. Here's 11. Then we can do 12, pointing down. 13, 14, 15, 16, 17, 18. Okay, we only need 2 more. We're at 18 here. So we need 2 more to get 20. 19, and then 20. So we didn't need to use the 3D orbitals at all. I just had them there to kind of show you at the start. So this is the orbital notation for calcium. If I were to write the electron configuration for calcium, it would be 1s, and then as a superscript, you put the number of electrons or the number of arrows, which is 2, then 2s2, okay? Then this guy has 6 electrons, so 2p6, 3s2, 3p6, 4s2. And then if you add up these highlighted superscripts, they're going to equal 20 electrons because we just wrote the electron configuration for calcium.